Today we'll be talking about my math assignment part 1 where I explain the process of the Euler's method. So here is a particular graph which I did it for my x0, y0, and this black curve is my true value curve and my blue curve is my predicted value of y1 and x1. So we all learned about gradient in secondary school, which is rise over run, and we're using the same method to derive our answer. So our slope is dy over dx x naught y naught, which is also equals to rise over run. So to find our f x naught y naught, it's going to be equals to y1 minus y0 over x1 over x0. In order to find our y1, it's going to be y1 equals to y0 plus f x naught y naught multiplied by x1 minus x naught. So x1 minus x0 will give us our step size h. So we're subbing in x1 minus x0 as h. So we use the value of y1 to calculate our y2. So y2 is going to be equals to y1 plus f x1 y1 h, and to find our x2 is going to be equals to x1 plus h. The equations above, if you now know the estimated value of y, then yi plus 1 equals to yi plus f xi yi times our step size. In x equals to 0 and y equals to 1, because I'm following the initial condition, y equals to 1, x equals to 0. N is the number of times to get x equals to 1 without using the step size, which is 10 times. For xn column, we use the step size to get 1, and yn is using the Euler's formula. For n, we're gonna use the formula from the previous number plus 1. So this will give us, I'm using a step size of 0.1, so it will give us, it needs 10 times to get x equals to 1. And for xn, we're using the step size, so we gonna use the formula plus the previous value plus 0.1. Then I'm just gonna do the same. dy over dx equals to x over y squared. So this is gonna be equals to the previous value plus and step size multiply by your given equation, subbing in your x and y of the previous values. So x is 0, so we just subbing in, divide by your y squared, the previous one, and square. We get 1, and I'm just solution for to find y1 is 1.33931. So by decreasing step size 0.01. We'll be using the GS method to solve the equation. We're integrating both sides first, then we sub c back into equation. We're working towards the goal to get y. Then to find 1, we need to sub x equals to 1 into this equation. Going via the GS method, we get y1 estimation 1.3572. And when using the Euler formula, y1 1.3391. So in conclusion, the approximation error using the Euler method with the step size of 0.1 is 0.0181, which indicates that it provides the reasonable estimation for the given IVP, though the accuracy can be improved with decreasing step size. I was showing how I got 0.0181. That's actually to find the error. All for my presentation. Thank you.